Hello everyone, my name is Camila. I'm currently joining STEMinPink as the Brazilian director, and today I'd like to share about technology with you, more specifically about inputs and outputs, as this is completely connected with the STEM field. And I'd like to advertise that I'm not a tech savvy, but I'm passionate about learning, more specifically about technology, and I truly believe that teaching and sharing knowledge is a wonderful way of learning, and it gives meaning to everything that I am looking for. So I hope you guys enjoy it, and I'd like to tell that we're going to create a project to apply this knowledge that you're going to learn today, and I invite you to try. But if you don't have the materials, you don't need to worry, as I'm gonna show you a website that you can create all digitally. So let's start. Well, I organized this presentation in order to make it clearly to understand, and I'd like to start by discussing what is an input. As it says, an input is any data or signal that is sent to a system for processing. And at this moment, I don't want you to think of a system just like a computer, an Arduino board, or codes and programming. I invited you to try thinking about a system as your brain. And I know it may seem awkward, but an input consists in a question. So if I make you a question or ask for you to do a favor for me, for example, could you turn the lights on, please? You're going to process this information and think about a possibility. So if you should turn the light on for me or not. And the action is going to be the decision you took. So in this case, an input is an external information, just like my question, and that is given to the computer, to this processor, in order to, it knows what to do. So it can be a sensor, it can be a button, it can be neutral language processor, it can be anything you want, and as long as we learn to discover many more possibilities. And here I bring some input devices that are currently present in our lives, such as the keyboard where you type information, a mouse that you can move freely through your screen in order to know to access all the resources, a joystick that allows you to move your avatar in your video game, and all of these are informations that are not given in your code. You are given it in the moment that you're using. So the same can be applied to many other things, such as pressing a button. And now, what is an output? As it says, in computing and electronics, an output is any data or physical action sent out of a system after it finished processing information. And if the input is the question, the output is the answer. So, reminding the example, I asked you to turn the lights on for me. You were processing this information, considering if you should turn the light on or not. And the decision you took is the output. The action you took is the output. So, for example, I'm going to consider that it turned the light on. So, this is the output of my question. And in this case, is the contrary, exactly the contrary. As I said, an input is a way that the external part can communicate with the internal part, with your processor, with your program. But the output is the way that your system can communicate and interact with the physical world. And this is also very present in our daily lives, such as the printer. It turns the digital files that are the input in paper. The speaker that transforms digital data into sound waves that we can hear. The same can be applied to headphones and the projector also works in a very similar way. You probably already noticed when I was explaining that all of these concepts work together, but it has a name, and it is called system theory. And the system theory is the study of how different parts can work together to create a whole. And if you look around to your devices, you're going to notice that all of them work in the same way. You need to touch the screen of your phone to turn it on and send information and move freely. and also your computer, you need to type and you need to use a mouse. So all of these resources are completely connected. In this case, I decided to bring an example. I consider an input a button that I can press, and when this button is pressed, the Arduino Uno is going to process the information, and finally, an LED will turn on, and this is the output. But now, it's time to code. So we're going to create a light traffic light project using an ultrasonic sensor. In this case, the ultrasonic sensor is going to be our input, as it is detecting the distance of objects through the use of ultrasonic waves, and it allows us to know how distant or how close an object is from the sensor. So it is capturing an external information, and the object in this case is our hands. When the object is very close, the red LED will turn on, and the lights are the output. When it is at a medium distance, the yellow LED will light up. And the last but not least, when it is far away, the green LED will shine. So now let's analyze how the inputs and outputs are defined in our code and how they work together. As you noticed, the outputs are the LEDs, but the way that we can know if it is the red, the yellow, or the green LED happens through conditions. The materials we're going to use are ultrasonic sensor, some jumper wires, a protoboard, an Arduino Uno board, and 3 220 ohms resistor, and three LEDs with different colors. And as I said before, you don't need to worry if you don't have the materials. We are going to simulate this project, and you're also able to use the same website that I'm using because it's free, so you can test your project there. I created a flowchart so we can understand better how this is going to work. First, you need to assemble the project according to the diagram, and then you need to upload the code to the Arduino Uno board, and for that you're going to use the Arduino IDE software. It is also free, but you need to upload in your computer, to download in your computer in case you don't have. And finally, test the project. This part is the most important part of this whole activity, because you're probably, if this is your first time ever creating a robotic project, this probably is not going to work at first. And I highly recommend for you to not give up. Give it a try and try again, because you're going to learn very much from mistakes. And this is one of the most important parts, because you never forget those concepts once you made a mistake and you understood and you could figure it out after. And we are going to recreate the same diagram in Tinkercad now. Let's go! So this is the website that I was talking about. It is called Tinkercad, and you can use it freely, so you don't need, I'm gonna let the link available in the description. And I've already created a part of the project here. You can have access to all of the components in this right section here, and if you don't find it, this part, you can search for it. Just one small advice, we have two different kinds of ultrasonic sensor, and you need to be sure that the one that you're taking contains 4 terminals, okay? And I've already filled this protoboard and all the bars here, but it still needs we still need to create the connections with the pin boards, with the LED and the ultrasonic sensor. So we need to take a look at the code to see if we can distinguish which one are the connections, so we can start to understand better and notice that this is not that difficult. Well, this is Arduino IDE. It is a software. In case you would like to use it, is for free, but you need to install it in your computer. So you can Google it and download it in the Arduino website. In this first part, we have some information about the Arduino, the ultrasonic sensor. In the void setup, we start having some things here that we are going to use. For example, as it is an output and we already know that the LEDs are our output, we can know that these 3 pins here, 2, 3, and 4, are the LEDs pins. But you're probably wondering how we can distinguish which one belongs to each pin. And the answer is in this condition. We can read here that if the distance is greater than 250, nothing is going to happen. But when the distance is between 175 and a number that is less than 250, the pin mode 2 is determined as high, which means that the LED is going to turn on. So if we are considering a big number and we determine that when the distance is big, the LED that's going to shoot up, that is going to turn on, is green, it means that the pin mode 2 is the green one. And we can do the same for the others. But we still need to discover which are the ultrasonic sensors pins, and the answer is also right here. Read ultrasonic sensor distance was determined in this third line here, and the integer is the trigger pin and the echo pin, respectively. So here 7 is the trigger pin and 6. To the Tinkercad, we already figured all of the pins, so we need to test. I pasted the code here so we can test. And in this part, I haven't tested yet, and I know that there is something that we need to change in order to make it exactly the way that I explained in the presentation. But let's see if you notice. We can change the distance in this case manually, as we cannot effectively measure here in this interface. But now, when the distance is far, the green LED is turned on. Okay, but when it is at a medium distance, either the green one and the yellow one are turned on. And finally, all of them, when this is really close. What we actually wanted is to turn only one of them on in each situation. So we need to make some changes in the code. I'm going to stop the simulation and I'm going to edit this code. We need to take a look at this part, the conditions. As I said, when it is determined as high, it's because this is going to turn on, and then when it is determined as low, it is turning off. Which means that if we simply change the word written here, we can have a different result. So when it is very distant, we don't need to worry because all of them are turned off. But when this is between 175 and 250, only the green one is turned on. Okay, this is exactly what we want. The changes need to be done in this part. So when this is between 100 and 175, both of them are turned on. And we don't want the green LED still on, so we can simply write low here. And when we want only the red LED on, we can simply change these both parts to low. And after that, we can try it again and see if it works. So let's start simulate again. When it is determined as really close, we can see that the red LED is turning on, but this time the other ones are off, which is a good sign that we made the changes correctly. And when it is at a medium distance, only the red LED is turning on. And finally, when it is far away from the sensor, we can see only the green LED turning on. So this is exactly what we wanted, and we did it. Well, that's it for today. Thank you for watching. I highly recommend for you to subscribe on our channel and follow us in our Instagram accounts so you can keep updated of every content that we're going to post in this channel. And let's spend STEMinPink together. Bye!